This is lesson 21 in algebra 2 called scientific notation and two statements of equality. Now with scientific notation, we're going to assume that you've already done scientific notation in algebra 1. So we're just going to get started on how to do some of these problems. So this is example 21.1. We have 0.0003 times 10 to the negative 6. And we're multiplying that by 4,000, and that's going to be over 0.006 times 10 to the 15th, and we're going to multiply that by 2,000 times 10 to the 4th. Okay, so some review on scientific notation. First bit of advice I need to give you is the decimal must always be in a position where there is only one digit to the left of it. Okay, so and that digit has to be a number larger than 1. So 0 doesn't work. Alright, so we've got to do some changing around here. So this has to have a digit to the right, and it can't be 0. Well, the only digit in here that's not 0 is 3. So we're going to have to move this decimal all the way over to a place after 3. And let's put a 0 there just to give us a place value. So we move that digit over how many units? 1, 2, 3, 4. 4 over to the right from where it was. Well, it already said it was 6 over already. And we're moving it another 4. So it's going to go to the right another 4. So that gives us 10 to the negative 10th, because negative 6 minus another 4, because it's going to the right, is going to give us to the negative 10th. That's what gets confusing. Is it plus 4 or is it minus 4? If you're moving the decimal to the right, it's going to be a minus. So we're going to subtract 4 from negative 6 and get negative 10. Alright, this one right here. The decimal is right here. It cannot be there. There can only be one digit to the left of the decimal. So we had to move this decimal 1, 2, 3 over. So that's going to be 10, and that's going to be a positive 3 because we move the decimal to the left. When we move it to the right, we subtract that number from the exponent. When it's moved to the right, we add it. Alright, and that's over. Now let's look at what we've got. That can't be there. It's got to be after the 6 so that there's only one digit to the left of the decimal. So again, I'll just put a 0 there, times 10. And it was at 15. And since we moved it this way, we subtract 3 from that. So we get 10 to the 12th. And the last one is a 2,000. And we are moving it from here 1, 2, 3. So 2.0 times 10, and we moved it to the left. So we're going to add those place values. We're going to add 3 to that 4 and get 7. Okay, so why did we do all that? Well, it just makes it easier. In fact, we can do this whole problem right here in our head, and that's what we're going to learn to do right now. So let's get a color on here that you can see. First of all, we're going to multiply that and that. And remember, when you multiply numbers with exponents, you add the exponents. So we're going to add negative 10 and positive 3 and get negative 7. Over, now we're going to do this one here. 6 times 2 is 12 times 10, 12, and 7 is going to give me 19. What is 12 over 12? Any number over itself is 1. And when we divide exponents, what do? You subtract. So we have negative 7 minus 19. 1 times 10 to the negative 26. So I found the answer to that problem without using a calculator at all. And that is it for how you do those, and we'll do a couple more in the problem set for 21. So continuing with lesson 21, we're in example 21.2, and it's a word problem, and it says the ratio of two numbers is 3 to 4. So that's the ratio of those two numbers. So I need to write a ratio of 3 to 4, but I don't know what those two numbers are. I know the top one is the numerator and the bottom one is the denominator, so I'll just call them n and d. So this ratio is the same as this ratio. It could be 6 over 8, right? Because 6 over 8 reduces to 3/4. It could be 12 over 16 because that reduces to 3/4. But we don't know exactly what they are, so we're just going to write them as n over d. What else do we know? We know that if we add the numerator and the denominator, the top and bottom number, we're going to get 84. So what are the numbers it's asking? So I've got two equations and two variables. So I don't like this fraction stuff, so let's go ahead and do cross multiplication to get rid of that. 3d equals 4n, and that just got rid of my fractions. And I am going to leave my n plus d equals 84 alone. Well, I've got a couple things I can do. I can use elimination and put 3d here, but that doesn't work because they're not on the same side of the equal sign, and it's going to make kind of a messy situation. So let's go ahead and use substitution. Let's make this n equals 84 minus d. So then I can take, whenever I see an n here, I can plug in 84 minus d. So let's do that. 3d equals 4 times 84 minus d. Okay, so it's just substitution like you have been doing. 4 times 84, 168, 336. That's just wrong that I can do that in my head. Minus 4d. Add 4d to both sides. It gives me 7d equals 336. Divide by 7. Divide by 7. And I get d equal to 48. So d is 48, and I know that n plus 48 equals 84. So it's real easy then for me to find what n is, and that would be 36. So the book found theirs different than I did, but we both ended up with the same answer. And there you go for that. Let's look at example 21.3. So in this one, they're just saying the sum of two numbers is 128. Alright, so I'm going to add two numbers together. We can call those anything we want. We could call those x and y if we want. The book called them L and S because one is going to be larger and one will be smaller. So that would be the reason that they did that. But you can use an x and a y or anything you want. But if you have large and small, it kind of makes it a little bit easier because the next part it says their difference is 44. Well, if their difference is 44, it's going to have to be the large one minus the small one to give you 44, because if it was the small one minus the large one, you would get a negative number. So for instance, if this was 20 minus 10, larger minus small equals 10. But if it were the smaller number first, let's say it was 6, minus the larger number, we would get a negative 4. And our answer that they give us is a positive number. So I know the bigger number has to be in front and the smaller one following. So anyway, that's why they did that. And I can't erase that. So let's scribble that out. And we'll use these two equations right there. So let's take, gosh, it doesn't really even matter which one you do. substitution or elimination. I guess I would probably use elimination because I've already got my positive and negative s's there, so that when I add those I get 0. So I get 2L equals 12, 1, 7, 172. Divide by 2, and I get 86 for my large number. So if I take my large number, which is 86, and I add my smaller one, I get 128. So subtract 86, and my s then becomes 42. So there's my small one, and there's my large one. And that's it for lesson 21.